Everyone, today I will explain how to solve problem G from Codeforces Educational Round 90. So in this problem we are given a chessboard of size n by n. Also we have a special column k. And in this problem we will be given also m updates or changes to the board. And during the i's change, so one pawn will be added or removed from the board. Yeah, and chessboard is considered to be good if you can place all pawns, or let's say move, if you can move all pawns to the special column by the following rules. Yeah, so here we have these following rules. Yeah, some of you could notice that the chessboard wouldn't always be good. Yeah, and here we have statement that indicates that we will need to fix it. So in order to fix it, we need to add new rows to the board, and since we moving all pawns like up, these new rows have to be added at the top. Yeah, so they will be numbered like n+1, n+2, and so on. And after of each update or change, we just need to answer the minimum number of rows which we need to add to make the chessboard good. So now I will just explain the example from problem statement, so to make it more clear. So now we have to add a pawn on cell 4-4, so we add it. So actually pawn can move to all these sides. So here, to place this pawn to the special column, we will just place it here. Okay, so as you can see, the answer is 0, so which means that we don't need to add any row. Okay, so now new pawn is placed on cell 3-5. So because that cell was already that cell wasn't free, so thus and only thus we just need to add a new row, and we will place that pawn here. Okay, and this is the reason why I answer 1. So because we need to add one extra row. Okay, so now we have a new update on cell 2-4, which is here. Yeah, and as you can see, so we can't place that pawn anywhere in this special column because all cells are already assigned to other pawns. So thus we need to add a new row. And yeah, and then we will just add this pawn here. Okay, and this is the reason why answer is 2. Okay, so next we have update on cell 3-4, which is here. Yeah, and so we can just leave it in cell 3-4. So that's answer 2. We don't need to add any extra row. So okay, now we have update on cell 3-5, so which is this cell. So which means that we just need to remove this pawn. So we remove this pawn, and yeah, we just remove this pawn, and as you can see, we don't need this seventh or second extra row in order to place that pawn. So because we can put it here. Okay, so thus we don't need this row, and the answer will be 1 for that final query. Now let's try to simplify the problem. So let's, for simplicity, let's say every time we get a pawn, so let's say for any pawn we will try to place to the smallest row as possible. So for example, we will just place that pawn here and that pawn here and that pawn here. Okay, so now as you can see, we don't need to add any row, but let's say we will have another pawn here. So and let's say we will add it here as well, but since we don't want to have more than one pawn in the same cell, so we will need to add one extra row. Okay, but for now, let's just write number of pawns in each special in each row of special column. Okay, so let me just write. So let me just write an array of, for example, of length 5 here. So we will have. So here we will have an array of length 5. And for example, in third row, we have one pawn. Okay, so let's call this array maybe counter. Okay, let's say counter or CNC. So yeah, in third row here we have one pawn. In fourth row we have one pawn. And in the final, like in the last row 5, we have 2 pawns. And yeah, in first and second we have zero pawns. So I think it's kind of obvious that if you have more than one pawn in a certain row, that you just need to propagate it to the right or to up. Yeah, which means that you add extra row. Yeah, let's just consider another example, but in terms of this array. Yeah, let's say we have another array counter. Okay, so maybe let's say that now it's bigger. Maybe let's say that initially it has nine rows. And yeah, let me just write like any random numbers for each row. Yeah, so I think that will be more clear. So if we'll just try to explain on that random array. So let's say we have maybe 0 pawns on first, second, then let's say 3 pawns here, maybe 2 pawns on sixth row, 1 pawn here, maybe 1 pawn here and 2 pawns here. Okay. So for example, if we have 3 pawns in third row, it's obvious that we need to leave 1 pawn here and propagate another 2 pawns like to the right. Okay, so yeah, so we will just add here 2 pawns and we'll leave 1 pawn here, right? Yeah, and we will just do the same operation, and finally we will know how many extra rows, how many extra rows we need to add. So here we just leave it as 1 and propagate 1 pawn to the right, and the same here. We leave 1 pawn here and propagate to the right 1 more pawn. So here we will have 2 pawns. We will leave 1 pawn here, propagate like add or shift one pawn to the right, so it will be 2, right? So but here I mean to the right, but actually it's like up, because I just represented this column with one array, like horizontal array. So here again we leave 1 pawn in row 8 and propagate 1 pawn to the right. So here it will be 3 pawns. Then we would need to leave one pawn here and propagate 2 pawns to the right. Yeah, and finally we would note that we will add, that we need to add 2 extra rows. So now, instead of thinking of this problem as a chessboard of size n by n, let's think of this problem as an array of length, let's say n, of length n, and on each query or on each change, we will either do +1 or -1 on a certain position. So we'll just think of this problem as an array counter, which stands for number of pawns in a certain row. Yeah, so as I just explained it, we can easily solve that problem. I mean, naively, but it will be slow. So I think that trying to answer one query will be of n, but you have m queries, so which will be of nm, which is quite slow. But for sure, we want to come up with a much more efficient solution. Cool. Now, if you know that actual answer for a query is a maximum value among all lower bound values, which is just I plus suffix I minus 1 for all possible i's where we can have a pawn. Okay, now I guess from that point we can easily solve, or sorry, we can easily maintain updates. So let's suppose we have an update. So we get a new pawn on position, let's say pause. Yeah, on position pause. So which means that suffix value for all positions from 1 to pause will change, will increase by 1, right? So if you add pawn, so you do just +1 on that range. Yeah. Let's suppose if you need to delete a pawn, all values for suffix in that range will be decreased by 1. Okay, so now we can think of a segment tree. Yeah, because segment tree can easily do such updates as for example as +1, -1 on the range on a segment easily. So yeah, each update we can just, I mean, in segment tree we can just store maximum value, and in each update do either +1 on a certain range or -1 on a certain range, and the answer will be just maximum value. Very cool. So here we have a segment tree with lazy propagation that can do +x on the range L R, and yeah, that segment tree stores maximum value. So here I have a function that can get maximum value on range L then R. So now let's get to the solution. So since we want to get such maximum value among all such positions, so and since we are always adding I minus 1, let's just add I minus 1 for every position initially. Okay, cool. Let's do that. Initially, yeah, I mean, that will be more convenient. So now we have updates, and I say that answer is initially equal to n. Okay, so now I have functions that process pawn. So new y coordinate of pawn will be y, like current y coordinate, plus how many units you need to move to get to the special cone. So this will be kind of new y coordinate, let's say new y coordinate. So if I didn't add that pawn yet, or this pawn is like is deleted. So we just need to do +1 on that range, because for every position in that range, I mean, number of pawns on that suffix will be increased by 1. And here I have a map set that stores all positions of pawns. So I do insertion of that position. Okay. Otherwise, if you need to delete a pawn, I do -1 on that range. And I delete that position of that pawn from multiset. So if I have if I have pawns on chessboard, sometimes chessboard might be empty. So but if I just need to get maximum value among all positions where we can have pawns. So this is maximum position. Otherwise, if you don't have pawns, so answer will be n. So here I just change the status of current pawn, and then if we need that many rows, we need that many extra rows. But sometimes this answer can be less than 0. This value, but actually answer in the problem cannot be less than 0. So thus I take maximum among 0 and that value. And I think that's it. And by the way, the time complexity of that solution is n plus m log n. So which is quite fast, and I think that this solution is really elegant. And yeah, I think that's it. So if you enjoyed this video solution, if you really did, so make sure to subscribe to this channel, press like button, and maybe if you have some questions, you can leave them below. I will try to answer. So yeah, what else? See you in the next video. Bye bye.